So, welcome to the first major tech hour of 2023, which is the third hour of the tech hour. This is the second time we've had one of these 2-hour meetings where three talks, a break of 5 to 10 minutes, and then discussion and panel discussion. And the theme is STEM access from author to reader. And I'm delighted that we've got 3 impressive speakers, all of whom have got first-hand experience of accessibility. And it's well known that you can't produce successful software, particularly user-facing software for people with disabilities, without the involvement of people who have the disabilities themselves. Of course, Godfrey will probably remind me that it's not people that have disabilities, it's the lack of social adaptations that is the cause of disability. Jonathan Godfrey is a senior lecturer in statistics in New Zealand University. Patrick Smyth works for City University in New York and has written a PhD on negotiating access, which is a humanities PhD, even though it's not about accessibility. And it's in the Department of Literature, as I recall. And Jason White, I know through the accessibility list on that the Tech Users Group provides. And he works for, is it an educational testing service in the United States? Perhaps you can introduce yourself when you...
So I did work there, but I decided to move on from that role in July last year. So, but yes, I have worked there and contributed to accessibility standards and research there, and I'll mention that briefly in the presentation. So.
Okay, so the speaking order will be Jason, Patrick, and Jonathan. So maybe just over to Jason.
All right. Let's see what we can do. And I apologize for some of this. I've had to swap computers in a hurry to try to join the meeting. So what I think I'll do is give a presentation that introduces some of the communities that I've been engaged with that relate to tech in one way or another. And then I'll have something to say about recommendations for making tech and low-tech documents more accessible, and some discussion at the end about some recent developments of interest. So I hope that sounds reasonable. So I first was introduced to Unix as a first-year undergraduate student 30 years ago, and Unix was the way in which one could access the internet in those days. It was the preferred option, but I'd also heard about it from other sources. I had friends who were using it at university themselves, and I remember reading a review of the OS/2 screen reader from IBM, which was one of the first screen readers for a graphical user interface environment in those days. And the reviewer commented that although OS/2 was a good operating system and the screen reader was effective, Unix was better. So all of those kinds of considerations sparked an interest, and I became quite interested in Unix as a first-year student. And of course, as you would expect, LaTeX came along with it. I should note that the Unix skills which I started developing 30 years ago have proven to be highly valuable since, and a very good long-term learning investment. So, of course, tech was already part of the culture. It was often discussed online, and it was also recommended to me by people whom I knew in person. And I remember investigating the potential for using it to typeset phonetic transcription as part of a course that I was studying in the grammar and linguistics of spoken French as part of my undergraduate program. what I found particularly interesting was the whole Unix tradition of separating typesetting from editing, which is very different from the way in which a word processor works, obviously. And when you're working non-visually, I find that having the markup explicitly included in the text in front of you is particularly useful. I remember at a conference which I attended some years ago now, a participant suggested that one way of identifying whether a word processor document was written by a blind person is to look for the formatting inconsistencies. For example, the text which has been pasted in from elsewhere, preserving the original fonts that are inconsistent with the remainder of the document. Now, of course, screen readers have ways of getting around that kind of problem, but you have to query it explicitly or configure it appropriately to do that. Whereas in a markup-based system, obviously the markup is included directly in the document at all times, and you can just edit that as needed. So I think that separation is useful from an accessibility standpoint. So I'd like to highlight 3 software projects that I became acquainted with in the 1990s, which were important for purposes of our discussion. So the first of these is T.V. Rahman's Asta software. He completed his PhD thesis at Cornell University in 1994, and his project was to develop Asta, Audio System for Technical Readings, which is essentially a speech-based reading and browsing environment for LaTeX documents. And so it used different voice characteristics and non-speech audio cues to convey the information very efficiently and clearly. It also had the ability to interactively read and navigate the logical structure of documents, including the complete structure of the mathematical expressions. All of this was implemented using an audio formatting language so that styles and speech rules for individual document components could be written very effectively and easily in that language. For instance, if you wanted to define a new tech macro or environment and prescribe how it was to be spoken or what kind of audio cue was to be used, you could do that in relatively few lines of code. Now, what's interesting about Asta is, first of all, that its capabilities were very impressive as a document reading application. I should point out that it was a research system, it wasn't a product, but it became available via the technology licensing program at Cornell University to other universities where there were students or staff members who were blind and who might need it. And that was how I obtained access to it. But what's rather disappointing, I think, is that even though the screen readers of today implement some of these features, they don't implement all of them. And so a research system from the mid-1990s in some ways outperforms the assistive technologies that people are using and relying on today. And I think that's rather unfortunate. There are reasons for that. Screen reader development is complex and they have to work around all the bugs and changes in other people's applications and the implementation of accessibility related programming interfaces. So it's not easy. They're under-resourced typically, and they don't really have a lot of scope for innovation. So there are reasons for it, but nevertheless, I think it's disappointing. The next project I'll refer to is another by T.V. Rahman, his Emacs Speak software, which was developed in 1995 and subsequently. I think the most recent release was in the second half of last year, as I recall. And as you may be aware, Emacs is a text editor, but of course it's much more than a text editor. You can perform basic web browsing, interact with email, work with diaries and calendars, write and develop software, edit markup languages, and do much more. I'm sure Emacs users will have their own list of favorite applications. And so, yes, Emacs is really a software development environment. It's been described by some of its proponents and detractors as an operating system rather than a text editor. And so TV Raman developed Emacs Speak, which is essentially a speech-based interface to Emacs. It's implemented as an Emacs extension, and it applies the principles and the ideas of audio formatting that I described earlier, which he had created in his PhD project, to providing an interface to Emacs and many of its extensions. And so what's interesting about it also is that it was implemented using the advice facility of Emacs in such a way that he didn't have to modify Emacs itself or its extensions. And that's rather different from the ways in which graphical user interface accessibility works, where the authors of graphical user interface toolkits and applications have to implement accessibility interfaces directly in those software components. And so you have to modify an existing component if it doesn't support accessibility already. And unfortunately, the history of these kinds of accessibility projects where large numbers of developers all have to implement something correctly and consistently has a haphazard record of success. And I think we've had great success in graphical interface accessibility in important respects. We certainly need it. But on the other hand, there's a whole story of bugs, implementation, limitations, and regressions as well. So I think that project is deserving of note. And I would also argue that we need more of these extensible software systems such as Emacs that people can make accessible without requiring application developers to do so much of the work. And if the software architects can find ways of doing that, I think we'd all be in a much better position. So the third project of note here is Braille TTY, and it was developed at some point in the 1990s. I think it was Cambridge University, but I don't remember the full history of it. It's basically a tool that provides Braille-based access, including navigation and reading of everything displayed on the Linux text console. It was later extended in conjunction with the Orca screen reader to provide access to graphical user interface environments under Linux, including the GNOME and Mate desktop environment. And it's a very interesting tool that supports a wide variety of Braille devices from different manufacturers. Unfortunately, the Braille display that I purchased in the mid-1990s wasn't supported until around 2005 for various technical and non-technical reasons. And so I had to keep using an old DOS-based system for a number of years just to support the Braille display. And of course, you can't simply buy another one because they're rather expensive. But I was involved in the testing of the driver, and that problem was eventually solved. So some brief observations then. I think I would emphasize the value of solutions which are developed by people who have disabilities to solve their own needs and to solve the needs of others. I think there is important value in the development of software by people who are not only creating the software, but who are also users of it, and in particular, who use it for purposes other than developing it. And I also would emphasize the value of what we might call user developer communities, in which users and developers cooperate to improve the software and to help other people to take advantage of it. I think in the free and open source world, we certainly experience that very regularly. I think a good example of this would be the environment that has been developed in conjunction with the R statistics package that Jonathan Godfrey has been extensively involved in, and the accessibility tools which have been created for that. So if I were involved in statistics of any kind or recommending it to someone, that's the project that I would definitely recommend. So what did I do with this low-tech business as a student and later as a scholar? Well, as a law student, I wrote law essays in it. My background is as a humanities student in French and philosophy with an undergraduate honors degree in philosophy and also an undergraduate law degree. So I certainly used it as part of my legal education. Then I went on to write a PhD in analytic philosophy of language in a good academic environment. And I used a combination of LaTeX with Emacs speak, with the AUC tech mode of Emacs and Braille TTY to write much of my PhD. And obviously I used revision control with that. And there was an occasional use of logic notation, but it was really just, for the most part, a very text-based thesis dealing with interesting issues in the foundations of semantic theory. In my later work, as a scholar working as Jonathan indicated at Educational Testing Service, I used tech to write papers and a book chapter. And in that environment, I basically set up a makefile that could convert documents both to PDF and to HTML. And I could review the work in HTML with a browser and then provide both the HTML and the PDF to colleagues or to journals, book editors, and whoever might need it. And so in that particular role, I suppose I should point out that it involved working on hard problems of accessibility in education. Hard problems, so-called, by my former colleague there, Mark Hakkinen. And those included in particular issues of mathematics and science accessibility, including participation in standards groups and research projects. I've recently published a paper on markup languages and accessibility, which deals more broadly with markup languages, including LaTeX, ASCII doc, Markdown, the editing environments that can be used for them across various operating systems, and some of the associated accessibility issues. It's intended to take a more objective view of the subject than I'm doing today. In the presentation here, I'm giving you the highly opinionated version, but in the paper, I try to give you a more objective, stand back a little bit kind of overview. So what are my suggestions then on LaTeX and accessibility? Well, I don't think they're particularly different from other people's suggestions. So I think making HTML and MathML output a first-class deliverable of the environment is valuable and important. I know there's been discussion of a possible pathway to doing this involving the implementation of tagged PDF. So, of course, the tech typesetter always produces PDF with a product. And so if it could include the document structure in that and preserve it in the typesetting process, I think that would be valuable. But of course, what users really need, I think, is HTML and MathML output. And it's been pointed out on the tech accessibility mailing list that there's already a specification for producing HTML from tagged PDF. So that's one route that we could go in. Obviously, there are already tools for producing HTML from tech documents, including Tech for HT and LWARP package, as well as and others. So we have solutions there, but I think we could further improve on those. If it can be done without requiring significant modification of packages, I think that would be particularly useful, bearing in mind the observations above regarding how people are not so good at dealing with problems that require large numbers of developers in diverse contexts to make changes to their software projects for purposes of accessibility. I think it's important to standardize and to continue to work on support for image accessibility and the accessibility of table structures. There's been some discussion associated with that. Providing access to source code, I think, is valuable because the user's tools may be better than yours. And so if it's possible to provide the source as an additional downloadable option, I think that would be helpful.
Jason, could
yes.
I
we're nearly finished if we're running into the time limit.
Yeah, 30 seconds is fine. But otherwise, we could pick it up in the discussion.
All right. So semantic macros, as David Farmer has called them, I think would be useful to try to disambiguate mathematical expressions. And then at the end of this, I just have a list of some of the interesting current projects that are underway that are of relevance that probably should be noted, and some of them are not really described in the paper. So maybe I'll leave that to the discussion, and sorry about taking extra time.
That's all right. I'm really grateful, and round of applause from everybody, so to speak. So next on is Patrick, who the last really eminent person in the digital humanities in the tech community was Sebastian Ratz, the founder of Tech Live and many other things. And his interest was archaeology and also the text encoding initiative, which has got a long history of using XML, because for them, the XML document is the document. Without anything more to say, I'll pass over to Patrick.
Excellent. Thank you, Jonathan. And I really want to say, Jason, a ton of crossover in our backgrounds and in some of the technology that we're using. And I was really excited to hear a call out for Emacs Speak, which is something I use. And I'm a pretty diehard Emacs user. I read my email in Emacs and all that kind of stuff. So great to hear about that and get that call out. So my name's Patrick Smyth. Got my background is in the humanities. And I'm a teacher and a writer and a programmer is usually how I kind of describe myself. And I run a small consultancy called IOTA School. But Jonathan proposed a pretty, what I kind of like, which is a structure that's kind of like a little about myself, a little about others, and maybe like some social structures and stuff. And then also some things, so the stuff we're kind of a little bit here for, like technology and the document formatting and all that kind of good stuff. So I will briefly talk about my background, which I think is relevant to some of the other stuff I'll discuss. And then I'll talk a little about some of the philosophy of how someone with disabilities might usefully conceive of their interactions with society in a really general sense, which is what my dissertation was about. And then I'll wrap up with some of the stuff that I've been working on, specifically related to accessible documents, but also just related to making things more accessible in general. So I won't go too much further back. I'll go very briefly on my disability and so on. So I have retinitis pigmentosa, and it was diagnosed at 14. And for a long time I said I was low vision. Now I'm more or less just say blind, but I have some residual vision. I have peripheral vision and stuff, and I can kind of walk around, not walk into things. Mostly, I use a cane, but sort of here sometimes, not all the time. And I don't have any central vision. So when I started a PhD in 2012 in English literature at that time specifically, it was one of the big challenges that I faced was getting access to books and other documents. And it's a very reading intensive PhD for obvious reasons, studying literature. And was finding that a lot of my energy went into scanning documents, trying to track down documents in like very inaccessible like databases and so on. And it really was very time consuming. It was a struggle, and it kind of shaped a lot of how I like thought about of like my research and so on. And so when in 2014, I had always sort of been interested in like web development, putting up websites and stuff in a sort of semi-technical way. And then in 2014, I sort of parlayed that into doing a fellowship, like to be a digital fellow. And when I joined that sort of organization within an organization, this digital initiatives at the Graduate Center CUNY, where I was doing my PhD, someone suggested that I start learning Python and with the programming language. And I took a summer and I was kind of playing around with Python a lot during the summer, and I found I really liked Python. I really liked how it gave me some control over the computer and how I interacted with it. And because I always felt like I was fighting with the computer because of my visual impairment. And the nice thing about programming, and then later learning other technologies like Linux and Unix and Emacs speak and other programming languages, was that I could just tell the computer exactly what I needed, and sometimes it would take a while to build the infrastructure that I wanted or needed, but it was possible, and I could invest some time now and some study and build some infrastructure that would be useful to me later. And it kind of led to a whole change in my career trajectory, where I spent more time learning digital humanities, this subfield in the humanities called digital humanities, and getting involved with initiatives to build infrastructure, not only for people with disabilities, but also like infrastructure for teaching, which is something that I'm very involved with. Recently I've graduated from the Graduate Center, and I'll get into some of the dissertation stuff in a second, but I'm now running a small business, IOTA School, which is kind of a infrastructure development and technical training consultancy that have a couple of clients, mostly working on accessibility related, but also kind of general infrastructure development work. And so that's kind of my background and why I sort of was so drawn to, and why, I don't know, like thinking about documents being accessible was kind of what made me get into technology in the first place. And so just switching gears a little bit, to briefly talk about this dissertation project that was shaped by this background in trying to make inaccessible things accessible. And that's the dissertation project called Negotiated Access. And one of the main concepts in it is this idea of hackccessibility, or basically using hacking to try to make things accessible, even if they're not. And people on this call are probably fairly familiar with the social model of disability, which essentially it's a way to think about disability that is very useful in advocacy and changing society. And it posits that disability, or like not being able to perform certain actions or go certain places or do certain things in society, is essentially it arises from the way that we create infrastructure and social structures that prevent people with disabilities from doing things. And then there's also a medical model that really focuses on kind of fixing disability and all that kind of stuff. So my dissertation kind of proposed something like it's an augmentation of the social model, but it kind of focuses more on that kind of space between the individual and society, and how the individual encounters society. And looking at, for example, in various kinds of infrastructure that people build that prevent individuals from doing the things that they want to do, and also how that like membrane between the person or the small group and the society can kind of be pushed against, with ideas like hacking things or building small like communities of practice that can really bring about like like change in that area. So some examples of like accessibility, I'll talk about some ones from the dissertation, and then I'll talk about one briefly for myself, and then I'll transition into talking about my some of the work that I've been doing. But so some examples of like accessibility are, for example, there was this individual in say who 5-6 years ago, or throughout the 20-teens, his name was Hugo Campos, and he had a pacemaker installed that required that his heart, the data, it monitored the state of his heart, and it generated a lot of data, but could only be read by a doctor with a specialized and like proprietary like system of to read his heart data. And subsequently, first of all, that's annoying because he couldn't look at it himself or monitor anything himself. But also, eventually, he lost access to his health insurance. He couldn't go to the very expensive cardiologist that installed the pacemaker and so on. And so he just was completely unable to read this data. And he wound up buying the expensive software, going to a training, like flying to a training that was only attended by other doctors, and like teaching himself how to read his own data with this expensive software that he purchased. And he then subsequently advocated for changing things up. But it kind of started with him just really individually wanting to read his own data. And then the advocacy and everything kind of came from that story of him being stymied, and him trying to come up with ways to kind of hack around this pacemaker. Another example that's kind of, I find a little bit moving actually, is that there are many, I mean, not many, but there used to be many, now there's few, polio survivors who required iron lungs, like a very dramatic medical intervention to be encased inside these giant machines that change the pressure to allow them to breathe. There used to be many of them, and eventually, as people got older and there were fewer survivors, those companies that created those machines shut down and no longer existed, and they didn't create parts, and they didn't maintain those machines at all. So those people who needed iron lungs, the few of them that survived, all of them essentially have someone in their lives who is essentially like a tinkerer or a hacker or someone of that nature who was able to kind of just like think outside the box and make sure those machines kept running. And I think that's another example of accessibility, or like realistically, like it's hard to imagine a relatively achievable social structure in a small amount of time that could have saved those people's lives, and it really kind of required an intervention from someone who was thinking in terms of like hacking and tinkering. So just transitioning now to a little of the projects that I've been working on. In my dissertation, I also write about using, like, I hacked in 2015. I jailbroke, which is essentially a form of hacking my iPhone, because I found that the voiceover was constantly stuttering and like getting held up for 15 seconds. So I changed it so I could like reset it really easily. And that was like a really like liberating moment that sort of made me want to write the dissertation and do all that kind of stuff. So right now, what kind of projects am I working on in this area? So I would say there's two related to STEM accessible documents. So the first is working with one of my clients is with IOTA Technologies, which is the sort of consultancy that I'm running, is Space Telescope Science Institute. So they perform the scientific operations for the Hubble and James Webb Space Telescopes, and they produce an enormous amount of both data, open data, and also scientific outputs. So you can kind of imagine they're like pre-paper sort of types of outputs. So they're HTML generated by Jupyter Notebooks, which is kind of a data science, very commonly used tool in data science. And these notebooks, they're kind of accessible right now, or pretty accessible, but the experience is not 100%, and it's kind of misses a lot of the context that is visual in a Jupyter Notebook. If you're familiar with them, they are a fairly visual paradigm, or at least as constituted right now. So we're working with a group of testers and some people like contributor to Core Python to try to make some of those outputs more accessible. And I will share a link after I finish that will bring you to the repository of what we're working on with some of the example notebooks and a description of what we've been doing. And my hope is that this grant will lead to maybe some more where we can tackle some of the more serious challenges around the Jupyter Python scientific stack. That, for example, making the editor so people could actually use the notebooks. That right now we're trying to use a Jupyter notebook as a blind data scientist or researcher is a very frustrating experience and could really be improved. So hopefully it will lead to future developments in that area. And then I would also say, and I'll wrap up now, Jonathan, for my business, I've developed a web application that I think represents some of the ideas that I have around making documents accessible. And it's a curriculum hosting platform and designed to be accessible from the ground up. And it's based on an idea that I've heard about described as malleable systems, but I think, like, for example, Emacs is one of these types of systems, a system that allows itself to be easily manipulated and hacked by other people, hacked in a good sense. And so that I feel like this platform that I'm working on, that some people are going to be piloting to hosting some of their curriculum on it in the coming months, and like you can reach out to me if you're interested in doing something like that too, is kind of also designed to be sort of accessible and hackable, and to be embody this idea of like accessibility where people are empowered to hack on their own stuff and do things for themselves. All right, thank you all.
Thank you very much, Patrick. And I really appreciated your examples of hack accessibility, not only for the examples, but the way in which achieving accessibility is a social matter. And it's quite partly a question of social skills, social attitudes, communities. Communities is who you know, and that's really important. So I'm really grateful for that. Can I impose on Shamsi and ask if she'd be willing to introduce Jonathan Godfrey for me?
Ooh, I can do my best. Let's see, we had the pleasure of interviewing Jonathan Godfrey for the research that we did at Archive recently, and he was so extremely generous with his knowledge and with his background. I was very excited that he was going to be part of the panel today. He, as many of you know, is a senior lecturer in statistics at Massey University, I hope I'm saying that right, in New Zealand. And he's also a powerful advocate in the disability community.
Thanks, Shamsi. Yeah, Jonathan asked us to talk about ourselves and then others and whatnot. And I have to say, blowing your own trumpet in my country is frowned upon. So in my notes that I'm going to give to Jonathan for sharing after this meeting, you won't see the Jonathan Godfrey biography. People can go and look for the track record somewhere else. What I'm going to do is I am going to share my screen and not my screen reader because I can't listen to it and think about myself at the same time well enough, and I certainly don't expect anyone else to listen to two things. Oh, host is disabled screen sharing. One of you needs to fix that, please. But I will say a little bit about myself. To my best understanding, I was the first person who was blind to gain employment as a lecturer in statistics anywhere in the world. And I found out by accident in the 90s when I was doing things tough on my own. I always assumed that I just didn't know where to find the other person or people out there that I needed to contact. Not that they didn't exist. I had personal contacts and would be passed on from contact to contact and to meet other people. And as that was an accidental process, I can't say that I ever expected to stumble across that person who was going to give me all the information I needed soon enough. So I had to go and find it out for myself. Life's a bit different 25 years on. I think the young people of today in that same circumstance that I found myself in 25 years ago have it much, much easier as a consequence of our ability to communicate better. Now, I found out that I was the first because when Theodore Lutz from South Africa was wanting to become a lecturer in statistics, he sent me an email and said, I want to do this and that and the other, and what do I need to know? What have you learned? And I gave him a whole list of my experiences, good and bad. And then I said, but you don't want to just take my version of it. You need to go and find the other people. And he wrote back and said, Jonathan, you are the other people. I can't find anyone else. And I, for 10 years, hadn't bothered looking for anyone else. There was no desire on my part to actually seriously look for that other lecturer in statistics who happened to be blind. I am pleased to say I know plenty of blind people who have completed a PhD in statistics now, and done it as tough as I did, sometimes tougher, but hopefully mostly easier. So let's see, share screen, basic tab. Right, we are now sharing the screen. Okay, so I've opened up an HTML page, and I won't read everything that's included in this document. I've written it so that it stands alone for anyone who doesn't watch the video afterwards. That's just the way I do things. But I start with the fact that later on today, I'm delivering a talk to the South Pacific Educators of the Vision Impaired Conference. These are mostly the teachers that go into the schools to support primary and high school kids in their education. The specialist teachers, we call them Resource Teachers Vision. I think in the US they're called TVIs, and the language seems to change all over the world. But they're the people who don't know how to use the adaptive technology, Braille, and the other skills that those young blind people need. And I'll be talking about why those staff and the parents of blind kids need to be looking at the tools that we as blind adults who are successful in STEM are actually using, and why those parents and specialist teachers need to be using those tools as well. Because the sighted high school teachers won't be using the tools that we as successful blind adults are using. And if the parents and the specialist teachers don't pick up those skills, then the next generation of STEM students will be doing it as tough as, or tougher, because now they're deluged with information of differing use, doing it as tough as people who are on this call today. My primary reason for going to this audience later today is because those young people do need to create documents that they can read for themselves and that can be then handed over to their vision-dependent teaching staff in their state school or university. I talk about the in that talk later on today. My abstract gives the rough blurb, and if anyone wants to go and look into it more deeply, there's a the full rundown of what I tell those teachers as well for you to look at. But I talk about the fact that a lot of time gets wasted by blind people because we don't know who to ask the right questions of to save ourselves from duplicating the mistakes that others have already made. And we've all done it. We've all done it as blind adults. And it's painful, it's frustrating, and usually it's just a waste of time. I certainly believe that to be successful as a blind adult, no matter what discipline you are working in, but especially in STEM subjects, you've got to be ready to change and adapt to new technologies. The world is changing out there in our disciplines, and if we don't change, we stand still, the rest of the world walks away from us. And so that's the message I'm giving to that audience. And it's the message that I'm giving to blind adults as well. The proof of the pudding for my money is that 2022 was the first calendar year in my life where I did not employ a sighted person to assist me in document preparation in any way, shape, or form. I marked all of the assignments that I set for my students. I proofread all my own work. And while Jason and Patrick have been talking, I've proofread this talk and still found typos. But even so, I don't care that I've got typos in my work as much as I used to, because it is so simple and easy for me to fix a typo on the fly if I do in fact find one. And what I would actually say is that I have now proven for myself, at least, that I'm actually more efficient than many of my sighted colleagues who refuse to change. And I think the reason for my money is very clear. It's because I've shaken free of the painful existence of working with Microsoft Word, and in fact also of working with LaTeX. And I've spotted a typo already, so I'm just going to quickly prove a point that I can quickly go and find a typo. There's the typo fixed, file saved. Come back to my HTML page. It'll catch up in about 5 seconds. I think I've timed it. And the problem is, of course, that the screen reader jumps back to the top of the HTML page. And it still hasn't caught up. I'm going to move on. But why am I so hell-bent on HTML? Right, it's caught up. Why am I so hell-bent on HTML? Well, in the end, my efficiency and my effectiveness as a blind person comes down to the fact that I need to be able to read stuff fast. I need the tools, the adaptive technology to work for me now as much as I possibly can. And the best developments on offer in the screen reader development community are almost invariably in the HTML space. Everyone else is playing catch up with HTML. Of critical importance, speaking to the converter perhaps in this forum, but the availability of mathematical content, tables and the like, and my quick navigation around a document are of huge importance to me in my day job. What I'm seeing, though, is that because I have embraced HTML and because other people in my working environment are doing so as well, our students are actually really enjoying it. It is much easier to change the color schemes, the font sizes, and all the things that matter to sighted students in the same vein as what low vision people are screaming for as well. So I'm supporting the actually non-existent low vision and blind students that I could be teaching because I'm using HTML for all of my students. I have to go back though, and let's have a little bit of a history lesson. 25 years ago, when I started to use the word blind to describe myself, writing mathematical expressions in Microsoft Word was practically impossible. And so the discovery that I could write LaTeX and generate my own equations was a groundbreaking moment for me, and really gave me the confidence to seriously contemplate starting a PhD. And so I still today credit LaTeX as giving me the power to do a PhD. But of course, I was able to write a document in LaTeX, but I wasn't able to read a document, or at least not in the way that the rest of people reading that document were going to do. So I was always asking other authors for their LaTeX source files. Can you send me the tex file, please? And then I discovered that we could convert, like Jason said, could convert our tex files into HTML. They weren't perfect, but they were readable. Including the maths, they were readable. And we learned lessons about not using epsilon and using the var epsilon for the equations, and little things like that, because it was easier to change and adapt our practices rather than go off and argue with the people developing MathPlayer, MathJax, screen reader support for mathematical equations and things. It was just easier to change the way the epsilon looked to the sighted world. But life has moved on, and starting around 8 years ago, practically every document that I initiated as the initial author was started in Markdown, and the R Markdown variant in particular. And I actually cannot remember the last time I opened a Word document with the serious intent of actually creating a document for someone to read. But it cannot have been more recent than 2017, and it's most likely around 2015. I actually haven't created a LaTeX document in the last 5 years either, or not by opening up a tex file and starting from scratch. And I'm providing a link that people can go off and look at a set of notes that are all created using R Markdown for a second year course in regression. I taught that course for the first time in this format semester 1 last year, 2022. That's the first half of the year. We start semester in 6 weeks' time. I'll be teaching it again. It will take me 5 minutes to reprocess all of those files and upload them to the web server. And all that will probably change is the date at the top of each page, indicating that it's 2023. But because I am using R Markdown, I can encourage my students to use modern practices in how they complete the same tasks that I am completing as a practicing statistician. So I am demonstrating, I am practicing what I preach, and because I am also giving them all of the source files for my work, I am giving them all the resources they can ever need to implement anything that I want them to implement, because I've already done it in front of them. We've got that sort of cooking show mentality. They're eating the cake, and they're being given all of the ingredients so that they can go away and make their own cake this afternoon if they want to. But R Markdown in its original form and its slight modifications over the last 8 years or so might be behind me. You know, I said we've got to be ready for change, and the next change or the next chapter in my journey is upon us now. So we're into a new flavor of Markdown, and it's a product called Quarto, Q-U-A-R-T-O. This is a standalone tool that is going to reprocess all of my old R Markdown documents. I have to do some modifications, slight, and we've got the tools to do those. But converting a set of lecture notes from R Markdown to Quarto Markdown is going to take me an hour or two per course, not per lecture, per course. The benefit of Quarto is that it stands alone from R. So Quarto can now be packed off to the blind STEM adult or student and offered as an alternative, even if that person is not going to use R, doesn't even have R installed on their machine. Primarily, Quarto has been designed for the two leading tools in data science, being R and Python. And so Quarto takes the best that Jupyter notebooks have to offer, that R Markdown has to offer, and delivers it all in a standalone product. So I've given the link for where you can go and get your Quarto journey started. So Quarto is free, open source, and operates on all the operating systems. So I've given the, that link's probably not going to work. I've got the example here. I've included some R code, just generating the mean of the numbers 135, trivial. It's 3, of course, and the standard deviation of those 3 numbers as well. So I've got some R commands embedded in here, and possibly the worst example of Python that isn't just hello world. I've named a variable in Python and then used it 2 lines of Python and got the outcome. Hello, Jason, Jonathan, and Patrick. Quarto documents are just written in plain text. So I have the where I've got the document being edited. Whenever I demonstrate how simple it can be, I go back to the simplest tool of all that Windows users have. It's Notepad. For its sins, it is Microsoft product. It's pretty hard to break it. Just leave the F5 key alone. And everyone's got it. Everyone using Windows has got it. I sort of work on the principle that if you're brave enough to be using Linux, you're brave enough to use better text editors than Notepad. And anyone in Windows who's using other editors obviously has had the skills already to do so. So if I use the worst example of an editor, people can go and do better. So I can read that input file because it's plain text. It's actually pretty readable as plain text because Markdown is very clean in terms of how much markup gets included in a document. It's much easier to read plain Markdown files on a Braille display than it is to read source LaTeX documents. And the outcome, of course, natively is this this web page. Now, the way I've got this going at the moment, a beautiful modernized approach for Quarto, is that from the command line, the Windows DOS prompt, don't ever lose your DOS education, anyone who's got one. I have a browser that is actively watching as I hit save in Notepad. It's looking for that source file to be updated, and the web page that I've opened is automatically being updated should I hit save in my editor. So I'm not, apart from typing in that single command line to get this web browser open, I'm not doing any more command lines to continually reprocess my file. One of my projects at the moment is to update my text editor for writing our Markdown documents so that it works with Corto. Rather unfortunately, that means that I have to expand my Python knowledge considerably, it seems. But I'm looking to get to the point where we've got a text editor that works for screen reader users, has hotkeys for doing all the cool things that you want to do fast that aren't available in other editors, and is going to eliminate the need for the user to work with a command line, as much as I think command lines are absolutely necessary for anyone seriously interested in a future in STEM to get to grips with. But I understand that you've got to get people past some of that pain. A little side note on Braille, and that is that when I do have my Braille display connected, it's currently sitting at the on the desk at work, unfortunately, I would be using 8-dot computer Braille because I am primarily, as a Braille user, worried about the syntax, brackets all over the place of 3 different kinds being important, a few other symbols that are outside the standard 6-dot system, and of course I want to be knowing when there are capital letters in the coding, because that's what matters in R and Python. So I'm using 8-dot computer Braille, and I seriously think that that anyone looking at being efficient and effective as a Braille user in STEM ought to be doing so as well, at least having a look and deciding that they didn't like 8-dot computer Braille. The joys of being the third speaker is, of course, that I get to listen to the other two and reflect on what you said. I think the 3 of us all have some similar experiences of experimentation as individuals, possibly with a little bit of guidance when we got to use our resources and our contacts when we could. But in the end, there's a lot of things that successful blind people working in STEM have in common. Things like good experience with command lines, good experience with Braille, good, and meaning good, I mean pretty good use of more than one screen reader at times. I would suggest that those DOS skills that Jason and I learned in the dark ages, it's amazing how many people want to learn those today. And the efficiency of being able to do things in more than one fashion and not be constrained by the Microsoft way in Windows. Jason mentioned files and source content. Well, I religiously include the link to my source content in my output files. I wish that was the norm for all documents as the default practice. It would be absolutely stellar if we could open up a PDF generated from LaTeX and up at the top there was download for all of the original source files sitting inside that PDF. It is theoretically possible. Patrick talked about communities of practice. It's a 21st century phrase for something that blind people have had for years. We were working with email lists before other people had email, and we were sharing knowledge. I was doing so 25 years ago. And my last comment, Patrick, you mentioned the pain and suffering of Jupyter notebooks. I suggest you will be one of the first people to go off and look at Corto. And you'll see I've left room for questions, Jonathan, because I love them. That better do me. I've overdone my budget big time. Thank you.
Okay.
Can I jump in with a couple of questions?
Well, I'm happy for you to ask questions. Shamsi's facilitating, but go ahead, please.
So we've spoken before, Jonathan. I'm Charles Frankston from Archive, Shamsi's colleague.
Yes.
You were talking about the benefits of Markdown. Do you know about MyST?
No, I guess it's going to be one of those plethora of other alternatives that are out there.
It's myst.tools. I've just recently stumbled across it. I don't know how much traction they've got yet, but it's basically Markdown on steroids, where they're in particular doing the things that Tech does, being able to do equations, tables, figures, Jupyter notebooks, etc. Where MyST is the source code, and Tech and JATS and other formats can be generated from it. I have not played with it yet. I just find it intriguing.
So I'm doing, when I've got to send in an abstract or the full paper for a conference, and they demand it in Tech format. That's nice. I've written it in Markdown, and I've processed it through to a PDF. And on the way, the source Tech file has been generated.
Yep.
And then I just flick that file off to them.
Yeah, well, these guys are basically giving. Sorry.
Yeah, my real need for, or what I see as the real need for many budding STEM students to consider, is that copy and paste for blind people is an extreme effort at times. And so being able to avoid copy and paste pain and suffering is absolutely massive. We have with Corto the ability to get R and Python and observable and schema and mermaid flowcharts into a Corto document. But the future does look like it will include other languages that are being used where people would be needing somehow to render their work into a deliverable document. And I think that's one of the biggest pain and suffering exercises that blind students will have in STEM.
I'd like to come in here, Charles, and say that now would be a good time for us to have a break. Stretch our legs.
I don't do breaks, Jonathan.
Well, you're very welcome to stay here, and the no break people can talk amongst themselves. That would be great. Okay. And if you've got questions, if you put them in the chat, then that will help the facilitators and it will help the speakers. I'm really grateful, Jonathan, for that. It's very, very impressive, and it has shaken me a bit as to some of the assumptions I hold. So